I've got some apples and lemons, an infinite population of both, with those two distributions. And the question says, what's the probability that 3 lemons are heavier than 2 apples? Whenever you see a probability question written in words, you should try and capture that in symbols. So I've done that. I've, first of all, registered the fact that it's talking about 3 different lemons and 2 different apples. If you watch the other video, you'll know that that's a big difference between multiplying a lemon by 3. But anyway, that's it. And the way you do this question is, I'm going to create a single variable and work out how it's distributed. So these 3 lemons are bigger than 2 apples. I've taken everything to the side and created an equals 0, because now I've just got one variable, this one here. So you should be thinking, what is the distribution of this variable? If we can work out the distribution, we can just do an NCD from 0 onwards. So what is the distribution of this? Well, first of all, what do you expect the average to be? Well, 3 lemons, that's 450. Take away 3 lemons is 303. Take away 2 apples, that's 300. I would expect this variable to have an average of 3. Now, what would you expect the variance to be? Well, the rule is, if they're all individual items from a distribution, you just add them up. So it is 8 squared plus 8 squared plus 8 squared. I'll write that as 3 times 8 squared. And it is, then I've got 12 squared and 12 squared. So that's 2 times 12 squared. Just put that on the next line. Now, do I subtract these or add these? What do you think? I've got my 3 lemons and I've got my 2 apples. And the answer is I add them. You always add variances because negative numbers are just as varied as positive numbers. And you could think of this as a negative apple. Well, it's just as varied as a positive apple. So you add up all of the variances in the question. So I've done that. There's the variance. So I can say that this single variable here, I'm thinking of it as a single variable, has this distribution. And the question is it bigger than 0? So what is the probability that my variable, I'm going to call that x, is bigger than 0? Well, let's just do an NCD. So I go down to distributions. It's a normal distribution. I want greater than 0. So I've used a tail right. The mean is 3. And the standard deviation is the square root of the variance. And then just run that. What is the probability of this happening? 55.4%. Really nice.